Let's add now one level of complexity. Let's go to 3 independent variables. So we'll conduct a 3-way ANOVA.
It's going to be a 2x2x4 between design. The independent variables will be 2 levels of sex, 2 levels of ethnicity, and 4 levels of age. The dependent variable is going to be pacer lapse. So there's going to be 12 unique subjects in each of 16 cells. Here's the variable view screen. Here's a partial view of the data view screen.
Once we've run SPSS, you confirm that you have the appropriate number of subjects. So you have a total of 96 males, 96 females, and so forth. Here are the SPSS results. Under significant effects, both sex and age are significant. Non-significant effects, ethnicity is not significant, and none of the interactions are significant.
There are 4 interactions: sex by ethnicity, sex by age, ethnicity by age, and sex by ethnicity by age.
We'll show you how to run this in SPSS in just a moment. Importantly, look at the F ratios and the significance levels to make a decision about which effects were significant. Do you need to do any multiple comparison techniques? Not for sex, but wait, sex was significant. But there are only 2 means, so you don't have to do a post hoc procedure. The males have a higher value significantly than do the females. What about age? Yes, you have to do one with age. Why? Because there are 4 levels of that factor.
And it was significant. Ethnicity, we don't run any post hoc tests because it's not significant. And as you remember, none of the 4 interactions was significant.
So you would go back then, after you've learned that there was a significant age effect, and go back and run, in our case, the Student-Newman-Coils multiple comparison procedure. Remember, contrast-based simple comparison, so you would compare each age with all other ages. Here are the results from the Student-Newman-Coils. Notice we're doing all pairwise comparisons, and we have 2 subsets. And what we've learned is that the 13-year-olds are significantly higher in pacer lapse than the mean for the 11-year-olds, but the means for the 11, 12, and 14-year-olds don't differ, nor do the means for 12, 13, and 14-year-olds. We chose to look at the post hoc procedures with Student-Newman-Coils. You could have used a variety of other multiple comparison procedures and perhaps arrived at slightly different results. We'll now illustrate how to get these results with SPSS.
Once again, here's our data view sheet for SPSS. We have sex in column 1, ethnicity in column 2, age in column 3, and pacer lapse in column 4.
Remember, we're simply running analysis of variance, but it's now a 3-way. So we go to Analyze, General Linear Model, Univariate. We take the pacer variable and put it as the dependent variable. We take sex, ethnicity, and age and put those as fixed factors, and then simply say, OK. Notice we didn't check descriptive statistics. So if you wanted the mean values, you should have gone through options and selected descriptive statistics. Here's the confirmation of the number of observations, and here's the ANOVA source table, which you've seen in the previous slide. Notice again that age is significant, so you need to go back and do a post hoc procedure. So to do that, you simply go back to do the same analysis, general linear model, univariate. In fact, this time, let's go ahead and choose those descriptive statistics. Choose options, descriptives, continue, post hoc. Post hoc is going to be run on age. So you put age in the post hoc test window. In our case, we like Student-Newman-Coils. Click on SNK, continue, OK. Here come our results. Notice now we get descriptive statistics. Might be helpful to interpret the results from that. As you scroll down, you'll see the ANOVA source table. and then the results of the post hoc comparisons, which we presented in the previous slides.